Right, so today we're going to be working on effects, content layer for effect, continuing from where we left off last time. And where did we get to last time? We implemented sources we improved sources, which are the part of content layer that will provide content to your app. And we started working on source plugins. So what I'm going to do is open source and have a quick catch up. So a source is a stream that has some output. Can fail with any error. Maybe we should remove the error type and just fail with a content layer error. I think that should simplify things actually. So get rid of error there. Provided is fine. And the output for a source contains how to provides helpers for retrieving the content, contains the fields that will be part of the document schema, and some metadata. And we defined a file system source. Okay. And source plugin. We started working on a unified one, which we use for passing markdown using remark. And because we changed the error type, we need to update this. Okay. So now effects can only fail with content layer error. Okay, that's better. I think the output type could be a bit better. Metadata. I think plugins should be able to add metadata. So maybe instead of meta, we use context again. So I think a couple of iterations back, I was using context, but the problem was the fields. So we moved to this output structure with metadata added here, but I think what we can do instead is add context back and do that. And then that way we can add things to metadata. Uh, and then file system meta would then become a tag. File system meta extends context start tag. Also submitter, sure. Effect, content layer core, source file submitter. Yeah. And then the shape will be path after pass and randomly path and then cool. And remove the underscore. Context is imported as a type. That's it. And then here, context equals there we go. And then that means our plugins can add metadata. Maybe we can add a meta context extractor. And then it'll just use a similar pattern. Context, meta. Okay, let's have a look at plugins again. And I think the unified plugin could add some output here. V file with output. Where is that coming from? V file. This thing? V file? No. V file. It's coming from a V file package. Okay. Is core edge V file? I'll quickly search npm. npm package V file. Yep, so it contains the types. We don't want to edit here. We want to edit in plugins. Yeah. Process promise v file with output. Type diff. What is that? V file with a result field. Okay. Plus unified output. Extends context. We import context. Nice. Tag. Content calls. That's not right. Let's plug in unified output. Maybe that. The v file is a class. Data history messages value map. I think this is fun. So the unified plugin will take a unified processor and a function that extracts the fields. Maybe we'll rename this to extract fields. It will take the v file and then it will build the processor. We will add the unified output to the metadata. Add a body field from the value. Maybe we'll just do that. Ooh, Maxwell might join us. I'll just grab a link for him. Invite. Copy link. All right, let's see if Max joins us. So we've Here we're processing the content, adding fields, and let's add a helper to add metadata. Meta. And here we'll take a tag, which will be a context.tag, and a value. And we'll output meta slash tag. And then for context, we can go context.add this context tag value. Great. Cool. So we go back here. We can go to add meta unified output vfile. Great. So now the unified plugin will add some fields and also add some metadata that we can use in other plugins if we want to. So now we'll update this, take the v file, and it'll return a body from v file.value. V file.data. Okay. What happens if we want to add remark plugins here? Also, does this strip the front matter out? I guess we can try it and find out. Let's build. New tab. Alright, how do we run this again? Six packages. CLI. Cannot find module effect schema. Oh, of course. I did update all the packages before, but forgot to update the config file. So now schema is part of effect. There we go. Cool, so it's outputting stuff. So content layer. Then what have we got here? We've got our output stream, output object. Well, our content helpers, our context metadata, which contains the file system meta, and the unified output, the v file. It doesn't look quite right. We want front meta in there. So we go back to source plugin, go back to our extract fields. front meta. Wait, we'll need to build. Oops.
Timmy.
Oh, there's Max. There you go.
Hello. Hello.
Can you hear me?
I can hear you. Can you hear me?
Yes, I can.
Excellent. I seem to have
Um,
lost the little nub on my headset. I'm just going to see if it's over here.
all right. What do we do without a nub?
You might have to listen to my heavy breathing.
Built. Run this again.
Right. Think we are SOL. So, yeah. How are you doing, my friend?
Pretty good. Um, just looking at the markdown plugin.
Nice.
And while you weren't here, I made a couple of changes to source. The first one being I removed the error generic and just fixed it to Contentlayer error,
Okay.
just to make the interface a bit simpler.
Cool.
And I made it so plugins could contribute to metadata by adding a context to output, which means we can do things like this. A plugin can take a source in and then add stuff to the metadata, like we
That's
do
cool.
with effect context. With
Yeah,
the
that's
idea
cool.
being in the computed fields or in other plugins, you could access the metadata from plugins.
Yeah, that's exactly what I was trying to go for in like the at least the mocked up document thingy.
Yeah.
I really wanted at least metadata from source, but having metadata from plugins is really cool as well.
And right now I'm just looking at the rehype plugin and trying to get the fields looking right. Um, and I think this isn't looking too bad. I'm just wondering, like, in the body, we want to make sure the front matter is stripped out
Right.
because at the moment that will render stuff. So I'm just going to
Well,
quickly Google remark strip front matter.
and what? How are you What? Where is the generated piece of this? Like, how's this being produced currently?
So the content layer config looks like this.
Okay.
I think for now, I want to actually remove these computed fields. So this is what our source looks like right now.
Okay. And
It's
unified.
taking,
Sorry. Go ahead. Go ahead.
and it's just taking posts from the scratch pad.
Okay. And then the unified remark plugin that you have there uh contributes what, if anything?
So it's kind of like it's using this unified plugin, which contributes unified output, which is kind of like the raw output from unified. this v
Okay.
file thing. And then it just adds some fields. And it uses these remark plugins here. But I guess if a user wanted to add their own remark plugins, then maybe we create like another abstraction for remark where you just add your plugins or provide like an array of plugins maybe.
Yeah, because I could see, well, like
So
the
I could,
current content layer allows you to provide like both remark and rehype plugins, I think.
yeah. Well, rehype is a layer on remark, isn't it? I don't know.
That I don't know. I know that a lot of tools separate them out, but
Oh, remark rehype strips it out, yeah. But I thought rehype goes to HTML. Do we want to go to HTML? I think on the Effect website, we have our own markdown renderer instead of HTML.
let me look.
Maybe we
Website.
don't.
Let's take a look because I don't remember. It's a while ago that we set all that stuff up.
Just look at the rehype, remark rehype readme.
So it looks like we use some remark plugins. We have the code import plugin. We have Shiki2 slash GitHub flavored markdown and MDX code meta. And then we also have
Okay.
some rehype plugins, which we have rehype raw. Then we have rehype pretty code, rehype slug.
Okay. Uh,
So probably like a similar interface where a lot of
yeah,
these tools I feel like take an array of tuples of the plugin and their config.
yeah. Um, well, I like the unified abstraction, but I'm not sure about the remark one. Because I know in the old content layer, this builder or the builder of the processor is kind of abstracted away, which
Yeah.
is a bit annoying if you wanted to add like asynchronous construction or something. Because I know Tiki 2 slash you it uses promises to create the remark plugin. So in that case, you would have to resolve that promise before constructing your processor. So it'd be something like 2 slash plugin equals live effect dot promise. And then you would build your 2 slash plugin in there and then return the processor.
Is the processor for your unified interface thingy here already an effect thing? Like, does it take an
Yeah, yeah,
effect?
it can take an effect.
Oh, nice. Okay, cool. Yeah, I mean, I think eventually we'll probably want to provide like the flexibility of adding additional whatever, but I feel like
Yeah,
the default ones you have here are probably fine for now. We could just like
yeah,
focus
right.
on content and stuff. But
Maybe we just quickly add rehype here. Just so we get HTML. Let me quickly find what we want.
There, I'll look at rehype. So rehype is a tool, transforms HTML with plugins. These plugins.
There's like a bajillion packages.
Yeah, it's a great ecosystem, but there is a lot.
Re. What do I need to add? Remark. Rehype document. Rehype. What does that do? Uh, what is what? What do I need?
So I think you need it's the same kind of builder interface, right? But then I think you need rehype parse. I think parse is the HTML. Plugin to take HTML as input and turn it into a syntax tree. Yeah, so we need rehype parse.
I guess we need remark rehype first. And
We're
then we need
probably
rehype document.
I think we need rehype well, I think we need rehype stringify, which is the thing that takes the abstract syntax tree and turns it
Oh, yeah.
back into
So does that
HTML.
rehype document kind of like wraps it with an HTML document, which is not what we want?
Yeah.
What is rehype format? Rehype format.
All of these like simple little
Rehype.
examples I'm looking at are rehype parse followed by something followed by rehype stringify.
So rehype formats HTML to make it look nice, I guess. Yeah, format white space. And then rehype stringify. Rehype stringify is the thing that actually serializes to HTML.
Yeah. So the current content layer, what does it do? It uses rehype stringify. There's a remark rehype or something. These might be old packages. I'm just looking at how it what it does here.
Did I already have a buffer? Yeah, I did.
So
Search.
you already have the thing that parses the front matter, right? For a remark.
Yes. There we go. So now if we just add rehype on top of this. Oh, they don't even use remark rehype here. Remark. Oh, yes, they do. Remark rehype. So we need to import that.
What is the difference between remark front matter and remark parse front matter?
I could have told you 2 weeks ago, but I've forgotten.
Let me look. Remark. Remark. Okay, remark front matter. Remark front matter. Is the remark plugin to support front matter? Sure.
So they put format there. Yeah, let's see what that does. So, yeah, that one first. Contentlayer config, and then go down here and use the remark. What? Am I getting type checking? Yeah, there we go. Save. Run. Okay, that looks promising. Got front meta, a body, and it's stripped out the front meta. I think that's enough for us to start turning it into the actual content. Okay,
Cool. It's cool stuff.
so we've put our output now. So we go back to our document builder service. So just to recap, this is taking in a stream of config and then pulling out the documents from the config. And then for every document, it's evaluating the source and logging errors if there are any. What is this any source? Okay. Um,
Yeah, I think internally we're gonna have
this
to work
should
with it
be
in a type unsafe manner, probably.
stream. Are we importing source here? No. Source dot output. We'll just do unknown now. And then for each, here we have our document and output. So we have our output here, and our output has fields in that metadata. So this is where we pass it to, well, essentially pass it to our schema, our document schema. And then evaluate the computed fields, I guess. Well, maybe
Yeah, I
first let's
guess.
just pass the fields.
Yeah, because we're gonna need the fields to run the computed fields through, right? And
Yeah.
then it actually, like, there is logic to how we built up the computed fields, so that it has to process them in groups sequentially, but every group can be processed concurrently. And I can explain what that means in a
Yeah.
second. But yeah, I think the first thing to do for sure is like grab the fields.
All right. So for that, we need schema. So we go schema dot decode unknown. No, that's not right. The document. Is the document itself a schema?
It was originally. I don't know if I still had it that way.
Okay.
I don't think I do
Uh,
anymore. I
where's
think
the
that
create implementation?
I'm pretty sure that the fields are just a struct
Okay.
of, so I think you have to schema.struct the fields. And then you can pass it to decode.
Yeah.
Unless we want to do that internally, but I think the types get all weird if you do that.
Right. Uh, I guess it would be nice. Well, let's just make it work for now. So it'll be schema. It is a little bit annoying that we're creating the schema for every document. So maybe here we'll go stream.let fields schema. Schema. No, no. Decode fields. Okay. So here we will, I guess, just log out the fields for now. PSX. Starting. Nothing. Let's just get some error in there. Alright.
Yay!
Schema's doing its job. Okay.
So we don't author.
I'm just wondering if there's an error in the schema. I guess we just skip that document and log the error. Just let everything grind to a halt. I guess everything should grind to a halt.
We probably want
But
to accumulate all the errors and then show them to the user somehow.
yeah.
In this case, in this case, I had
We just log the error and then retry forever. Just so if you then kind of like make a change to the config, it restarts. No, it's not a good idea. Well, to do what I'm thinking, we'll need to add it to this flat map in here.
So what are you thinking we need to do there?
Map effect, and then what? And then move this in here. Remove the forever. What I might do actually is flat map switch. So if a new config change comes in, it interrupts the previous build and starts again. Okay. Right?
So now in theory, like we get this error,
We get this error.
and if we go try to fix it,
So if we go content layer, config, let me just see what our content looks like again. Scratchpad, posts one. There's title and author. And author is just a name. So if we do schema dot non-empty string here, it passes. Great.
yay!
Nice. And maybe we need to debounce somewhere because we got two builds there. Where should we do that? Config builder, I think.
Yeah, probably like that or the ES build, like where we're streaming out the ES build results, maybe.
Okay. ES build
Oh, we're actually
results.
doing it like
Maybe let's do it when we're in the stream.
yeah.
Changes, filter map. Identity stream dot debounce. Maybe
I don't know, 200 millis.
200 millis. Oh, I just did that. Save. Interesting. I guess my Vim must be deleting it and then recreating it.
Yeah, that's kind of interesting. Do you have swap enabled in NeoVim?
I think so.
I don't know.
Oh, who cares? We're getting fields back, which is great. Using the field schema.
Yeah, this is great. Let's see if we can. I think like it would be even cooler if we could like actually get some computed fields building as well. That would be interesting.
Okay. We need to import effect. Yeah. How does nested front meta work?
I think you would just build up and maybe try building up like an YAML object. What do I even have the author object looking like?
Just YAML. What was it? Name and Twitter.
I honestly don't know.
Twitter was
Yeah,
optional.
Twitter.
So we go back and then change it back to author. Nice.
That's awesome.
All right. We're building stuff.
Stuff is
Stuff
building.
is building.
It only took 4 weeks of streams.
Yeah, we're only working on it once a week.
For like an hour,
Yeah.
so yeah.
So what's the structure of a computer field? It has a description, schema, and a resolve.
Yeah, so the idea here is that the resolve function gets some arguments and then uses the resolver schema to validate the return type.
Oh, yeah.
And it's also like type safe. And then the other thing about this is if you notice, you can add like multiple groups of computed fields. The way we decided to do it was like you have an array of fields, and every group can be run. Every group is run sequentially one after the other because previous groups have access to the next group's computed fields. But every group itself can be decoded concurrently.
Okay.
So like when we try to like performance optimize, that's like something to keep in mind.
So we need to call resolve, and then with that output, validate it with the schema. And then
and would it make sense for us to take in a context here, or would like we literally put that into the context of the effect?
So this context would be straight from the output from the source.
It just seems awkward to work with a context as an argument. We could try it and see what it feels like, but
okay. So if we go back to document order. Resolve computed fields.
look at Copilot.
So we would have the document. Fields and source. And then we will have the output. I think
We probably also want to take in the decoded fields, right?
Oh yeah. So for each, we want to resolve each group concurrently. So what
each individual group will be concurrently, but the groups should be done sequentially.
Gotcha.
Because previous groups get fed into subsequent groups. So we probably also have to keep track of like the groups we've resolved.
So it's a read-only array
somewhere.
of...
Look, I even gave you a spec in the JS doc.
Oh, okay.
So
it's flattened
groups
into
are resolved
a
sequentially.
nested array.
Yeah,
Gotcha.
because I think when I construct the computed fields, I made it into like an array of arrays.
Yes. fields. Do computed fields just get added to the fields? Where do they go?
There's a computed fields portion of the document
Oh, here we're
that should be just
not really defining the output shape here, are we?
no.
Which would be the type that we'd write to the disk.
Well, the type that gets written to disk should be the same thing as fields,
Yeah.
right? Eventually a record of string unknown, but
Options,
yeah,
document, computed fields. Fields would be the initial thing.
yeah.
Fields, and then come the group. Yep. Vector for each group. Field. This will be our computed field definition.
And it has a name added to it.
Cool.
Because when you specify the group of computed fields, there's obviously like a name associated with it, so you can
Yeah.
use that to like give it the key. And the computed fields are safe on a type level for like preventing key collisions. So you don't have to worry about that when you're actually writing the code, unless you want to be like super pedantic.
That's
But like,
so we're reducing this array, and for each group of fields, we resolve them concurrently.
yeah, and the group we can do concurrently.
And then we'll get the values back, which be an array. And then we need to turn that, for each value, we need to add it to the fields group.
One thing that you might want to add to the for each is after a resolve has been called, you probably also want to validate the output of resolve against the schema.
We do.
But that can be a later step.
Well, we can just do that here. At the end of the resolve. Fixed.flatmap schema.move. Validate field.schema. What does it validate do? Doesn't have a return type there. Validate takes an unknown, ensures it's a. Yeah, that's fine. Alright, so for every group of computed field. Oh, yeah, here we go. So for every group, we go for each field concurrently. This formatting is confusing me. There we go, it's better.
Me too.
So it's resolving the field,
Yeah, this is
validating
good.
schema, and then we get the values and add them to the fields. Where is it getting indexed from? Yeah, that's fine. I would personally use this. Great. Yeah, we get back a pass error, which is fine. Okay. So we've got the fields, and now we can bind the computed fields. Oh, we'll just add it to the end of this, wouldn't we?
Yeah.
Because it adds the fields to the existing one. Flat map.
Yeah. Because
Fields.
eventually, like, you want fields and computed fields to be merged together. So I think this is perfect. Like that.
And then we can do this concurrently. All right. Run.
So we should get a bunch of errors.
That worked.
Yeah, it worked. Wait, did it
Oh,
work?
no.
Wait, go back to the output.
I was going to go.
Hey, go to
That we want.
the config.
Yeah, we want to see what config's doing first. So it is just slicing it. Not a very good slug.
Fields.title. Yeah, well,
Taking the first 5 characters.
yeah,
So it is working.
it is indeed doing what it's supposed to. That's fantastic.
Slug 2 is exactly the same. Great. There we go.
This was basically a test to try to prevent key collisions. So
This.
super cool. Now, yeah, this is very cool.
Great. How we do for time?
That's a good point.
I think going
I
about
probably
now.
need to go.
Yeah, I think that's a natural stop point.
This is great though. This is very, very good progress.
Yeah, I think next time we need to look at what the structure will look like, because we need to add the metadata to this.
Yeah. And we need to like play around with actually using the metadata
Yeah,
to basically see if like how it feels and whatnot.
and then we need to start saving it to disk somewhere.
Yeah, I feel like the key value store is going to be really nice here because you could basically have like underneath the hashed content layer config wherever we're going to save it. You could basically have like a file per document that's associated with the ES build hash, and then that's a easy way to cache things as well. Is kind of like doing it that way.
All right. Quit. Let's commit this. What? Nice commit message.
So many whips.
Yeah. Whip.
Cool.
All right.
Thank you, Tim.
Thank you, Max.
Hope you have a good rest of your day.
You too.
Cheers, folks.
See ya.